On a quiet September morning in 2019, automated telescopes scanning the southern sky detect something unusual. The object appears as nothing more than a faint smudge against the star field, dimmer than anything the human eye could perceive. It moves with purpose through the constellation Telescopium, carrying within its trajectory the mathematical signature of impossibility. The computers dutifully record its position, brightness, and motion. Unaware they have captured light from what might be another reality entirely. The discovery unfolds with characteristic astronomical patience. Days pass before human eyes examine the data. Weeks before the significance becomes clear. This visitor from beyond carries a designation that will puzzle scientists for years. Atlas, the third confirmed interstellar object to grace our solar system with its presence. Unlike the rocky wanderer Oumuamua or the icy comet Borisov, this object seems to whisper of origins that challenge our understanding of cosmic possibility. The light reaching Earth's detectors began its journey, perhaps millions of years ago, when early humans were learning to control fire. It travelled through the vast emptiness between stars, carrying information encoded in photons about temperatures, compositions, and gravitational histories that may belong to no universe we recognize. Each captured photon represents a quantum messenger from realms that exist, perhaps in parallel to our own realities, where the laws of physics bend in subtly different directions, where matter organizes itself according to alternate mathematical principles. Observatories across the globe turn their attention toward this cosmic enigma. The Mauna Kea telescopes pivot on their mechanical mounts, their mirrors gathering ancient light with mechanical precision. Radio dishes rotate across desert landscapes, listening for whispers of electromagnetic radiation that might carry signatures of alternate cosmic evolution. The Very Large Telescope Array in Chile coordinates its 4 8-meter mirrors, combining their light-gathering power to peer deeper into the object's mysterious nature. Each facility operates according to protocols developed over decades of stellar observation, yet none were designed to analyze visitors from parallel realities. The object's spectrum reveals absorption lines that don't quite match terrestrial databases, suggesting chemical compositions forged in stellar furnaces operating under unfamiliar rules. Silicon appears in isotopic ratios that shouldn't exist according to standard nucleosynthesis models. Carbon shows molecular arrangements that hint at formation temperatures impossible within our galaxy's stellar populations. Iron displays magnetic properties that suggest interaction with magnetic fields operating under different fundamental constants. These subtle anomalies accumulate like whispers, each one insignificant alone but collectively painting a picture of origins that transcend our cosmic neighborhood. The motion defies gravitational choreography that governs objects born within our solar system's influence. Traditional Keplerian mechanics predict elliptical or parabolic trajectories for bodies influenced solely by our sun's gravity. Yet 3I Atlas follows a hyperbolic path that suggests arrival velocities exceeding escape velocity by margins that shouldn't occur naturally. The mathematics describing its approach speak of acceleration phases that occurred long before our sun's gravitational influence could affect its motion, implying propulsion mechanisms or gravitational histories that belong to no stellar system within our local galactic neighborhood. Computer models struggle to recreate the object's trajectory using known physics. Simulations incorporating galactic rotation, stellar perturbations, and interstellar medium interactions fail to produce arrival conditions matching 3I Atlas's observed properties. The object behaves as though it emerged from gravitational wells deeper and more complex than any structure our universe contains. following mathematical curves that require initial conditions impossible to achieve through standard stellar formation and ejection processes. As autumn deepens and 3 Atlas continues its ancient journey, a curious irony emerges. The same quantum mechanics that allows particles to exist in multiple states simultaneously might permit entire universes to branch and diverge from quantum decisions made at the universe's birth. The visitor's strange properties become less mysterious when viewed through this lens, not impossible, but simply following the physics of a reality that took a different path 14 billion years ago. Only took the infinite creativity of quantum mechanics to make such visitations possible, after all. The object dims with each passing night, its light redshifting as it accelerates away from our sun's gravitational embrace. Photometry reveals brightness variations that suggest rotation periods inconsistent with gravitational disruption models. The surface reflects sunlight in patterns that indicate mineral compositions formed under stellar radiation environments unlike anything within our galaxy's chemical evolution history. Each measurement adds another layer to the mystery, another data point suggesting origins that transcend the boundaries of our cosmic reality. Yet something about its recession feels different from ordinary celestial mechanics, as though it follows invisible currents that flow between dimensions we cannot perceive. The Doppler shift of its reflected light suggests acceleration profiles that don't match gravitational models, hinting at forces that operate according to physics we have yet to discover. The object moves through space like water flowing downhill along channels carved by gravitational rivers that exist in dimensions perpendicular to our 3-dimensional experience. The photons continue their patient testimony, each one carrying information about a cosmos that might exist just beyond the reach of our most sensitive instruments, separated from us by barriers thinner than thought itself. These electromagnetic messengers traveled through interstellar space for eons, preserving within their wavelengths and polarizations the signature of whatever stellar environment gave birth to their carrier. They speak of temperatures, pressures, and chemical processes that occurred under physical laws that parallel our own, while differing in subtle but fundamental ways. Night after night, telescopes track the visitor's slow fade into cosmic distance. Amateur astronomers in backyard observatories contribute their own measurements, adding to the global effort to understand this enigmatic wanderer. University students analyze spectroscopic data for their dissertations, unaware they might be studying evidence of parallel cosmic evolution. The object continues its patient journey outward, carrying within its trajectory and composition the accumulated evidence of a reality that branches away from our own, like quantum possibility made manifest in stone and ice. Only took 14 billion years of cosmic evolution to deliver this messenger to our doorstep. After all, only took the vast patience of interstellar space to preserve its testimony across the light years. Only took the curious intersection of parallel realities to allow such visitation in the first place, as though the universe itself occasionally permits glimpses across the infinite landscape of what might be. The mathematics reveals itself slowly, like frost forming on a window in time-lapse photography. Orbital mechanics specialists feed 3I Atlas's positional data into sophisticated software packages, watching as the computational algorithms trace backward through gravitational history. The resulting trajectory curves through space with hyperbolic precision, describing a path that requires arrival velocities of approximately 44 kilometers per second relative to our Sun. Such speeds suggest the object originated from regions of space where gravitational potential wells exceed anything found within several hundred light-years of our solar system. Traditional stellar ejection models fail to explain such extreme velocities. Even the most energetic close encounters between massive stars and their planetary systems rarely impart escape velocities exceeding 20 kilometers per second to rocky debris. The galactic center's supermassive black hole could theoretically accelerate objects to higher speeds through gravitational slingshot effects. Yet 3I Atlas's trajectory shows no evidence of having originated from Sagittarius A's vicinity. The object approaches our solar system from the direction of the constellation Lynx, a relatively quiet region of local space containing no known gravitational anomalies capable of producing such extreme acceleration. Computer simulations explore increasingly exotic scenarios. Perhaps 3I Atlas experienced multiple stellar encounters, each one adding incremental velocity through chaotic three-body interactions. Perhaps it originated within a dense stellar cluster that has since dispersed, carrying within its motion the gravitational memory of long-vanished companions. Perhaps it formed within the accretion disk of an intermediate mass black hole, gaining velocity through magnetic field interactions during its earliest epochs. Each hypothesis generates testable predictions, yet none fully account for the object's observed properties. The hyperbolic excess velocity presents a particularly elegant puzzle. Objects entering our solar system from interstellar space naturally follow hyperbolic trajectories due to their arrival speeds exceeding local escape velocity. Yet 3I Atlas's hyperbolic excess measures nearly twice the galactic orbital velocity of nearby stars. This suggests the object's motion through space reflects not merely ejection from another stellar system, but acceleration through gravitational environments that operate according to different fundamental relationships between mass, space, and time. Astrodynamics specialists calculate the object's past trajectory with increasing precision, tracing its probable path backward through galactic space. The orbital integration algorithms account for stellar perturbations, galactic rotation, and gravitational influences from known massive objects within our local neighborhood. Yet the resulting trace leads to empty regions of space, cosmic voids containing insufficient matter to explain the object's extreme velocity. It appears to have emerged from gravitational histories that left no trace in our observable universe, following mathematical curves that require initial conditions impossible to achieve through conventional astrophysical processes. The mystery deepens as researchers examine the object's approach. Geometry. 3I Atlas entered our solar system from a direction that suggests minimal gravitational focusing by our Sun's gravity well. Objects approaching from interstellar space typically experience significant trajectory modifications due to solar gravitational influence. Yet this visitor maintained its hyperbolic path with stubborn mathematical precision. The calculations reveal an object that behaves as though it follows gravitational laws that differ subtly from Einstein's general relativity, operating according to field equations that incorporate additional dimensional parameters we cannot directly measure. Only took centuries of mathematical development to create the computational tools capable of recognizing such anomalies. After all, Newton's inverse square law provides the foundation. Einstein's curved spacetime adds relativistic corrections, and modern numerical integration algorithms trace the resulting trajectories through four-dimensional spacetime with unprecedented accuracy. Yet none of these mathematical frameworks adequately describe 3I Atlas's behavior, suggesting the need for physical theories that extend beyond our current understanding of gravitational phenomena. The object's velocity profile presents additional complications. Spectroscopic measurements reveal Doppler shifts that confirm the calculated approach velocity, yet subtle variations in the redshift pattern suggest acceleration components that don't match standard gravitational models. The object appears to experience forces that operate perpendicular to our three-dimensional space, as though it moves through gravitational fields that extend into spatial dimensions we cannot perceive directly. These forces manifest as tiny but measurable deviations from purely hyperbolic motion, creating trajectory modifications that require exotic physics to explain. Theoretical physicists propose various explanations involving extra-dimensional gravity. Perhaps our familiar three-dimensional space exists as a membrane within higher-dimensional space-time, allowing gravitational influences to propagate through bulk dimensions we cannot access directly. Perhaps 3i Atlas originates from regions where the geometry of space-time itself differs from our local cosmic environment, following geodesics through curved space that incorporates additional geometric parameters. Perhaps the object carries within its motion the accumulated influence of gravitational sources that exist in parallel branes, parallel universes that share the same higher dimensional space, while remaining otherwise isolated from our observable reality. The calculations continue with relentless mathematical precision. Graduate students verify orbital parameters using independent software packages, cross-checking their results against international databases of astrometric measurements. The numbers refuse to change, persistently describing an object that shouldn't exist according to conventional astrophysics. The hyperbolic trajectory remains stubbornly impossible, requiring velocities that exceed anything our galaxy's gravitational architecture can produce through known mechanisms. Radio telescopes search for associated electromagnetic emissions that might reveal the object's internal structure or composition. The Very Long Baseline Array coordinates observations across continental distances, using interferometry techniques to resolve details smaller than the object itself. Yet 3i Atlas remains electromagnetically quiet, reflecting sunlight with the passive indifference of ordinary rock and ice, while following trajectories that suggest anything but ordinary origins. The mathematical impossibility persists with quiet confidence, like a theorem that proves itself through the simple act of existing. Each new measurement confirms the hyperbolic parameters. Each refined calculation reinforces the velocity anomaly. The object continues its patient journey through our solar system, carrying within its trajectory the accumulated evidence of gravitational histories that transcend the boundaries of our cosmic neighborhood. Only took the infinite patience of mathematics to reveal such profound mysteries. After all, only took the stubborn persistence of numerical precision to illuminate the impossible. The spectroscope becomes a time machine, dissecting light that carries chemical memories across interstellar distances. Each wavelength represents a quantum transition between electronic energy states, a molecular fingerprint preserved within photons that began their journey when mammoths still roamed Earth's frozen landscapes. The infrared spectrometer aboard the James Webb Space Telescope detects absorption features at wavelengths corresponding to water ice, carbon dioxide, and silicate minerals. Yet the precise frequencies reveal isotopic ratios that challenge our understanding of stellar nucleosynthesis. Water molecules embedded within 3i Atlas's surface contain deuterium concentrations that exceed predictions for objects formed within our galaxy's chemical evolution history. Standard models of primordial nucleosynthesis suggest deuterium to hydrogen ratios should decrease over cosmic time, as stellar fusion processes preferentially consume heavy hydrogen isotopes. Yet this interstellar visitor displays deuterium enrichment levels that require formation environments with neutron densities impossible to achieve within conventional stellar cores. The isotopic signature whispers of nucleosynthesis processes that follow different reaction pathways. fusion cycles that operate under physical constants subtly modified from our universe's fundamental parameters. Silicon isotope analysis reveals even more puzzling anomalies. The object's silicate minerals show Psi-29 and Psi-30 concentrations that don't match any known meteorite classification or stellar nucleosynthesis pathway. These heavier silicon isotopes typically form through neutron capture processes within massive stars during their final evolutionary phases. Yet the observed ratios require neutron flux densities that exceed anything achievable within conventional stellar environments. The silicon speaks of formation within stellar cores that burned brighter and longer than physics should allow, following fusion cascades that produced element abundance patterns impossible under our universe's nuclear reaction rates. Carbon isotope measurements present equally mysterious signatures. The C12 to C13 ratio suggests formation within stellar environments, where the carbon-nitrogen-oxygen cycle operated under modified reaction cross-sections. This nuclear process, which powers stars more massive than our Sun, depends on precise quantum mechanical probabilities that determine how efficiently carbon nuclei capture protons to initiate the fusion cascade. 3EI, Atlas's carbon signature requires these probabilistic parameters to differ by small but significant amounts from laboratory measurements, as though the object formed within a universe where quantum mechanics operates according to slightly altered mathematical principles. Mass spectrometry analysis of sublimated gases reveals organic molecules with unexpected chirality preferences. Amino acids detected in the object's coma show left-handed to right-handed ratios that differ from both terrestrial biology and meteoritic chemistry. This molecular handedness reflects fundamental symmetries in electromagnetic interactions during chemical bond formation. Yet 3I Atlas displays preferences that suggest formation under electromagnetic field conditions, unlike anything found within our galaxy's stellar populations. The organic molecules carry within their twisted geometries the memory of formation processes that followed alternative pathways through chemical possibility space. Trace element analysis uncovers additional anomalies buried within spectroscopic noise. Rare earth elements appear in abundance patterns that don't match any known stellar nucleosynthesis sequence. These heavy elements typically form through rapid neutron capture processes during supernova explosions, following well-understood nuclear reaction networks that produce characteristic abundance signatures. Yet 3 Atlas's trace elements suggest formation through R-process nucleosynthesis that operated under neutron capture cross-sections modified from standard nuclear physics predictions. The rare Earth signatures speak of supernovae that exploded with energies and timescales that differ from conventional stellar evolution models. Only took billions of years of stellar evolution to establish the chemical abundance patterns we observe throughout our galaxy, after all. Only took the patient accumulation of supernova explosions and stellar mass loss to enrich interstellar space with the heavy elements that form rocky planets and complex molecules. Only took the precise calibration of nuclear reaction rates to create the isotopic signatures that allow us to trace chemical evolution across cosmic time. Yet 3 Atlas appears to have formed within a cosmic chemical environment that followed different evolutionary pathways, creating abundance patterns that require alternative histories of stellar nucleosynthesis. The infrared spectrum reveals crystalline silicate features that suggest formation temperatures inconsistent with conventional solar nebula models. These mineral phases typically form through slow cooling processes within protoplanetary disks, allowing silicate crystals to grow according to thermodynamic equilibrium conditions. Yet 3I Atlas's mineral spectrum shows crystalline structures that require formation under temperature and pressure gradients impossible to achieve within standard accretion disk models. The silicates speak of crystallization within protoplanetary environments that operated under modified thermodynamic relationships, perhaps within stellar systems where the fundamental constants governing atomic interactions differ subtly from our cosmic neighborhood's values. Polarimetry measurements add another layer of mystery to the chemical analysis. The object's reflected light shows polarization patterns that suggest surface mineral orientations inconsistent with gravitational accretion processes. These polarization signatures indicate crystalline alignment patterns that typically result from magnetic field influences during formation, yet the observed alignments require magnetic field strengths that exceed anything found within conventional stellar environments. The polarized light carries information about formation processes that occurred within electromagnetic environments unlike anything our galaxy's stellar populations can produce. Ultraviolet spectroscopy reveals absorption features corresponding to exotic molecular species that shouldn't exist under standard interstellar chemistry conditions. These molecules require formation through chemical reaction pathways that depend on precise energy level spacings within atomic and molecular systems. Yet the detected species suggest formation under radiation environments where fundamental constants governing electromagnetic interactions differ from laboratory measurements. The ultraviolet signatures speak of chemistry that followed alternative reaction networks, molecular formation processes that explore different pathways through the vast landscape of chemical possibility. The chemical fingerprint accumulates like archaeological evidence from a civilization that never existed within our cosmic history. Each isotopic ratio adds another data point. Each molecular signature contributes another piece to a puzzle that challenges our understanding of cosmic chemical evolution. The spectroscopic analysis continues with methodical precision, revealing chemical memories that preserve within their wavelengths and frequencies the accumulated testimony of formation processes that transcend the boundaries of our observable universe's chemical possibilities. The vacuum between galaxies hums with invisible possibility, a quantum symphony played in frequencies beyond human perception. Within this apparent emptiness, virtual particles flicker into existence and annihilate within timescales shorter than thought itself, their brief dance governed by Heisenberg's uncertainty principle. Energy and matter emerge from nothingness, exist for quantum moments, then vanish back into the probabilistic foam that underlies all physical reality. These quantum fluctuations create temporary violations of energy conservation that nature permits, provided the borrowed energy returns to the vacuum before cosmic accounting can detect the theft. Theoretical physicists propose that these quantum fluctuations might serve as doorways between parallel realities. The vacuum state that appears empty to our instruments actually seethes with virtual particle pairs, photons, and field excitations that exist in superposition states spanning multiple possible outcomes. Each quantum event represents a branching point where reality splits into parallel histories, following all mathematically permitted pathways simultaneously. The many worlds interpretation of quantum mechanics suggests these parallel branches persist as equally valid realities, separated from our observable universe by barriers thinner than probability itself. Advanced quantum field theory calculations reveal how virtual particles might occasionally achieve sufficient energy density to create temporary bridges between parallel vacuum states. These quantum tunneling events operate according to probability amplitudes that decrease exponentially with the energy barrier height, yet remain non-zero regardless of separation distance. In principle, Quantum objects could tunnel between parallel universes through vacuum fluctuations that temporarily violate the energy conservation laws that govern classical physics. The tunneling probability depends on precise mathematical relationships between field coupling constants and dimensional parameters we cannot directly measure. The Casimir effect demonstrates how quantum vacuum fluctuations create measurable forces between closely spaced conducting plates. Virtual photons exist in greater variety outside the narrow gap than within it, creating radiation pressure that pushes the plates together with force proportional to the inverse fourth power of separation distance. This phenomenon proves that quantum fluctuations produce real, measurable effects within our observable universe, suggesting they might similarly enable real interactions between parallel realities separated by dimensional barriers we cannot perceive directly. Quantum chromodynamics reveals additional mechanisms through which vacuum fluctuations might enable transdimensional communication. The strong nuclear force operates through virtual gluon exchanges that create complex field configurations within the atomic nuclei. These gluon fields exhibit topological properties that could theoretically extend into spatial dimensions beyond our observable three-dimensional space. Virtual gluon loops might occasionally achieve sufficient energy density to create temporary connections between parallel nuclear configurations, allowing information or matter to slip between realities that share the same higher dimensional quantum vacuum. Zero-point energy calculations suggest the quantum vacuum contains infinite energy density distributed across all possible field modes and frequencies. This energy remains unobservable under normal circumstances because we can only measure energy differences relative to the vacuum ground state. Yet gravitational effects might allow vacuum energy to influence space-time geometry. If parallel universes share the same quantum vacuum while existing in separate spatial dimensions, vacuum fluctuations could create gravitational influences that propagate between realities through higher dimensional space. Only took decades of experimental verification to establish quantum mechanics as the most successful theory in physics history. After all, only took the patient accumulation of precision measurements to reveal the probabilistic foundations underlying physical reality. Only took the mathematical genius of physicists like Heisenberg, Schrödinger, and Dirac to formulate the equations governing quantum behavior. Yet these same equations suggest possibilities that transcend our everyday experience of singular, deterministic reality, opening doorways to parallel worlds that exist in quantum superposition with our observable universe. Inflationary cosmology provides additional mechanisms for interdimensional particle transfer. During the universe's earliest moments, exponential expansion drove quantum fluctuations to macroscopic scales, creating the density perturbations that eventually grew into galaxies and galaxy clusters. Yet inflation theory predicts multiple bubble universes forming within the eternally expanding quantum vacuum, each one following slightly different evolutionary pathways determined by random quantum events during their formation epochs. These parallel universes might occasionally intersect through quantum tunneling processes that operate across higher dimensional boundaries. String theory frameworks suggest even more exotic possibilities for transdimensional object migration. The theory requires additional spatial dimensions beyond our observable three, with fundamental particles corresponding to vibrating strings that extend through this higher dimensional space. Different vibrational modes correspond to different particle types and properties, yet string interactions might occasionally couple modes that exist primarily in parallel dimensional configurations. Objects could theoretically migrate between parallel three-dimensional spaces through string interactions that propagate through the additional dimensions required by consistent string theory formulations. Experimental tests of quantum vacuum effects continue to probe the boundaries between theoretical possibility and observable reality. Researchers use laser interferometry to measure Casimir forces with unprecedented precision, searching for anomalies that might indicate coupling between parallel vacuum states. Particle accelerators probe virtual particle interactions at energy scales approaching the Planck threshold, where quantum gravity effects might enable temporary connections between parallel spacetime geometries. Each experiment adds another data point to humanity's growing understanding of quantum reality's vast landscape. The quantum vacuum remains fundamentally mysterious despite decades of theoretical and experimental investigation. Its apparent emptiness conceals infinite complexity, probabilistic structures that govern how reality unfolds from quantum possibilities into classical experience. Virtual particles dance through this invisible realm according to mathematical rules we have learned to describe but never fully comprehend, their brief existence creating the foundation upon which all physical phenomena build their temporary manifestations. 3IR Atlas moves through this quantum environment like a macroscopic test particle, its trajectory potentially influenced by vacuum fluctuations that operate according to modified field equations. If the object originated from a parallel universe where quantum vacuum parameters differ subtly from our local environment, it might continue to interact with its native vacuum state through quantum entanglement effects that transcend dimensional boundaries. The visitor carries within its motion the accumulated influence of quantum processes that operate beyond our ability to observe or measure directly. Only took the infinite creativity of quantum mechanics to make such visitations theoretically possible. After all, only took the mathematical elegance of field theory to reveal doorways between parallel realities. Only took the patient persistence of virtual particles to maintain connections across dimensional barriers that separate possible worlds from our singular experience of quantum collapse into classical certainty. The many worlds interpretation unfolds like origami in reverse, each quantum measurement unfolding reality into infinite parallel sheets. Hugh Everett III first proposed this radical framework in 1957, suggesting that quantum superposition never actually collapses, but instead branches into separate realities where each possible outcome occurs simultaneously. Every quantum event splits the universe into parallel versions, creating an ever-expanding tree of possibility where consciousness experiences only one branch, while countless identical copies explore alternative outcomes. The mathematics remains elegantly simple. The Schrödinger equation evolves deterministically through time, with apparent randomness emerging only from our limited perspective within a single branch of the universal wave function. Quantum decoherence theory explains how these parallel branches become effectively isolated from one another. Environmental interactions cause quantum states to lose their coherent superposition properties, preventing different branches from interfering with each other through quantum mechanical phase relationships. The process operates with ruthless efficiency in macroscopic systems, creating the illusion that quantum possibilities collapse into singular classical outcomes. Yet the mathematics suggests these alternative branches persist as equally real parallel universes, evolving according to identical physical laws, while remaining forever isolated from direct observation or communication. The branching process begins at the Planck scale, where quantum uncertainty reaches its fundamental limits. Virtual particle fluctuations within the quantum vacuum represent continuous measurement-like interactions that split reality into parallel configurations differing by single quantum events. Each virtual photon emission, each spontaneous particle decay, Each quantum tunneling event creates new branches in the universal wave function. The splitting rate approaches astronomical proportions, with reality fracturing into approximately 10 oscillons new parallel universes every second as quantum processes unfold throughout cosmic space. Cosmological implications of many worlds theory extend far beyond terrestrial quantum mechanics. The cosmic microwave background radiation preserves quantum fluctuations from the universe's earliest epochs, when inflation stretched microscopic quantum uncertainties to galactic scales. Each temperature fluctuation in the primordial radiation corresponds to a quantum measurement that split early reality into parallel evolutionary pathways. Some branches developed into universes closely resembling our own, while others followed alternative histories where stellar formation, galaxy evolution, and planetary development proceeded according to different random quantum outcomes. The branching structure creates vast parallel spaces where every possible quantum history plays out simultaneously. In some branches, quantum events during stellar nucleosynthesis proceeded differently, creating alternative patterns of element abundance that would produce objects like 3I Atlas with impossible isotopic signatures. In other branches, quantum fluctuations during galaxy formation led to different stellar population distributions, creating gravitational environments capable of accelerating objects to velocities that exceed anything possible within our branch of reality. Statistical mechanics within many worlds frameworks reveals how parallel branches might occasionally interact through quantum tunneling between adjacent possibility spaces. The probability amplitudes governing these inter-branch transitions depend on the quantum mechanical overlap between nearly identical parallel states. Objects that exist in quantum superposition across multiple branches might occasionally tunnel from one reality to another, carrying with them the physical properties and historical memories of their alternate origins. Only took the mathematical genius of quantum mechanics to reveal reality's infinite complexity. After all, only took the patient development of wave equation formalism to describe how possibilities evolve through time. Only took the intellectual courage of physicists like Everett to accept the mathematical implications regardless of their assault on everyday intuition. Yet many worlds theory makes specific, testable predictions about quantum behavior that distinguish it from alternative interpretations of quantum mechanics. Quantum computing research provides indirect evidence for many worlds phenomena through the behavior of quantum algorithms. Factorization algorithms like Shor's algorithm achieve their computational advantage by exploring multiple solution pathways simultaneously, effectively utilizing the parallel processing power of quantum superposition states. The exponential speed-up suggests quantum computers access computational resources that exceed anything available within classical single-universe frameworks, implying interactions with parallel computational branches that exist within the universal wave function. Bell inequality violations demonstrate how quantum entanglement creates correlations that transcend classical spacetime limitations. Entangled particles maintain mysterious connections that operate instantaneously across arbitrary distances, suggesting their shared quantum state extends beyond our observable three-dimensional space. Many worlds theory explains these correlations through shared quantum information that exists simultaneously across multiple parallel branches, with measurement outcomes creating correlated branch selections that preserve the appearance of instantaneous communication. Quantum interference experiments reveal how alternative quantum pathways contribute to observable phenomena even when they remain undetected. The famous double-slit experiment demonstrates how unobserved quantum possibilities influence measurement outcomes through constructive and destructive interference patterns. Many worlds theory suggests these interference effects result from interactions between parallel branches where particles follow different trajectories, with the interference pattern representing the aggregate influence of all possible quantum histories. The cosmic landscape of parallel realities extends infinitely in all directions through possibility space. Each branch contains conscious observers who experience their reality as uniquely real and fundamental, unaware of the vast parallel populations exploring alternative quantum outcomes. Some branches develop civilizations that discover many worlds theory through their own scientific investigations, while others follow intellectual pathways that lead to entirely different understandings of quantum reality. The diversity of parallel developments approaches true infinity as quantum branching continues indefinitely. 3 Atlas might represent a macroscopic quantum object that tunneled between parallel branches during its journey through interstellar space. If the object originated within a branch where quantum events proceeded differently during the early universe's formation epoch, it would carry isotopic signatures and velocity characteristics that reflect alternative stellar evolution and galactic formation histories. The visitor's impossible properties become explicable as testimony from a parallel reality where physics followed identical mathematical laws but different quantum random outcomes. The many worlds interpretation whispers of infinite parallel populations, each one convinced of their reality's fundamental nature while remaining forever isolated from their countless alternatives. Quantum mechanics becomes a theory not of probabilistic outcomes but of deterministic evolution through an infinite landscape of parallel possibilities. Every quantum measurement splits observers into parallel copies who experience different outcomes, creating a vast branching structure where every possible quantum history unfolds with equal reality and mathematical precision. Only took the infinite creativity of quantum superposition to populate reality with its parallel alternatives. After all, only took the mathematical elegance of the Schrödinger equation to describe how these possibilities evolve through time. Only took the intellectual honesty to accept mathematical implications that transcend the limitations of everyday experience. Cosmic strings stretch across the universe like scars left by reality's violent birth. Topological defects frozen into spacetime's fabric